Physics is actually a branch of science that involves the study of matter and the relationship between them. Welcome to Easy Physics. A lot of things has been advanced with the principle of physics. We talk about buildings, the building of our structured buildings. We use the principle of physics to calculate the loads, the forces, the tensions, the compressions, the deflations, and a lot of formulas. So physics is a very, very much practical subject. I would like you guys to actually create interest. It's very sweet, it's very interesting, it's lovely, and I'm telling you, it's real. So today, we are going along with physics, but I'm here to make the calculations very easy for us in solving a lot of questions, and I'll try as much as possible to be practical a bit and be much more realistic. Then today, we want to talk about the measurement, the fundamental quantities. Then two, we have the derived quantities. Yes. Fundamental quantities, the derived quantities. Fundamental quantities, they are the fundamentals. They are quantities in physics in which are independent on other quantities. The other quantities depend on them. So they are kind of the basic quantities. Other quantities derive their units. So, and the derived quantities are quantities which depends on the fundamental quantities for their existence. So now we want to talk about the basic fundamental quantities now. The basic fundamental quantities. We have, yes, the units, then the unit abbreviation. Yes, the main quantities are one, we have the length, two, we have the mass, and three, we have the time, then we have temperature, then we have the electric current. Yes, but the basic, most important ones of all these five, they are the length, the mass, and the time. What's the unit? The length is measured in meters, so the unit is meters. Then the mass is measured in what? In kilogram. Then the time is measured in seconds. Then temperature is measured in Kelvin. Then the electric current is measured in ampere. Yes. So as we move further in our subsequent topics and calculations, short form of representing this meter is M. Then this kilogram, kg. Then the seconds, x. Then the Kelvin, which is temperature, K. Then the current, which is ampere, we have A. So these are the basic fundamental units, and other units got their units from these basic ones. So we want to briefly talk about some. So the first one now, let's take into consideration area. Area of a place, area of a shape, area of a substance, area of environment. So what's the formula? The formula is actually length times breadth. Length times breadth. So if it is length times breadth, or let me put it this way, let me write the short form, length times breadth. So what the unit of length is meter. What the unit of breadth is meter. So we can say M, we can do it this way, okay. Length times breadth is equal to M times M. Because length is in meter, breadth is measured in meter, so we can say at the end we have M times M to give us what? M squared. So the unit is meter squared. Now the next one we can say we have volume. The formula for volume is what? Length times breadth times height. We can simply say length is measured in meter, the breadth is measured in meter, the height is measured in meter with respect to the fundamental what quantity. So we can say meter times meter times meter. So it's going to be what? M times M times M, 3M, we have M cube. So that's the unit of volume gotten from the derived, the fundamental quantity. Now the next one. Speed is what? Speed is distance over time. So I can say D all over, let me use short, small symbol, lower case, D all over T. Distance over time. So distance over time, so what's the unit of distance? It is actually what? Length. And length is measured in what? Meter. So we can say meter over the unit of time, which is S, is what? Seconds. Seconds. So we can now say meters per time can be written as M meter per seconds. Yes, meter per seconds. So the next one is, let's use velocity. Velocity and speed are actually the same thing. The difference between velocity and speed is that velocity is a vector quantity, while speed is a scalar quantity. Velocity has a specific direction, speed does not have a specific direction. So let's move to for acceleration. Acceleration. Yes, acceleration is actually the rate of change of velocity moved with time. So you can see acceleration is actually speed in a specified direction with time. So I can say acceleration is S, speed over time. So what's the unit of speed? The unit of speed is what? We have unit of speed gives us meter per second. So we can say meter per seconds over seconds. Yeah, because the unit of time is what? Is seconds. So meter per seconds over seconds, it will give us, at the end of the day, it will give us meter per second square. Yes, by the time we evaluate these seconds, it gives us meter per second square. So now the next one is what? The next one is we can talk about force. Yes, force. Mass. We can say mass, which is what? The unit of mass is kilogram. We can say kilogram times acceleration. And acceleration, what is the unit of acceleration? Meter per second square. So kilogram times acceleration. So this kilogram is mass, acceleration is m per second square. So when you combine these two things, it becomes kilogram meter per second square. So kilogram meter per second square can also be written as what? Newton. So kilogram meter per second square is written as Newton, represented as what? F. So F means, so that name for kilogram meter per second is what? Is Newton. So you can say the unit of mass is kilogram meter per second square or Newton. So the next one is 6, which is work. What is work? Work is actually force times distance moved in the direction of force. Force times distance. Let's just use it as force times distance. So we can say force. So what's the unit of our force? We can say the unit of our force is kilogram meter per second square, kilogram meter per second square times distance, d. So kilogram meter per second square, by the time you multiply this, d, which is distance, is measured in what? In meter. So let's replace the unit of distance as meter, m, meter. So kilogram meter per second square times meter, it becomes what? Kilogram, then meter times meter, it will give us meter square, then per second square. So kilogram meter square per second square. In other way, or in another word, we can say it can be represented by what? By joule. So the unit of work is joule. Kilogram meter per second can be represented as what? Joule. Yeah. So same thing as what? Energy. Same thing as what? Work. Work and energy has the same what? The same unit. Or we can also say, since this is kilogram meter per second, which is Newton, so we can say times M. So Newton meter can also Newton times meter to give us Newton meter. So work can be represented by kilogram meter square per second square. It can be represented by joule, and it can also be represented by Newton meter. Now the next one we are going to talk about is density. What is density? Density is actually mass over volume. So density is what? Mass over volume. So what is mass? Mass is kilogram, which is what? Kg over volume. What is volume? Let's come back to our initial question. Volume is m times, which is m cube. So we can say the unit of density is kilogram per meter cube. Kilogram per meter cube. So that's the unit of density. Then the last one, we are going to treat as regards the right point is number 8, power. What is power? Power is work over time. Work over time. So what is the unit of our work? The unit of our work is kilogram meter square per second square, or joule, or Newton meter. So let's use joule. So the unit of our work, let's make it joule. And what is the unit of time is what? Seconds. So joule per seconds is the unit of our power, or we can say joule per seconds, or work over time is regarded as watt. So the collective name for joule per seconds is what? Watt. So the unit of power is what? Watt. So those are the basic derived quantities we are going to treat. There are a lot of them, but you just understand how we derive this, and note that the derivation are actually with respect to the fundamental quantity length, mass, and time. Length, which is what? Meter, always make reference to the meters. Then the time, making reference to the seconds. Then the mass, which is kilogram, are making reference to what? Kg. You can see kg, so and so on and so forth. So that's it. That's little we can treat as far as introduction to physics is concerned, because these quantities will help us to derive the units, and those are the units placed forward before us. So we are going to use these units to solve a lot of questions. So when you understand this, you'll be able to use the formula to be able to solve different questions. Thank you very much. It's nice meeting you. Please click on the subscription button as I update you with wonderful, beautiful videos on classic physics. And I'm telling you, you are going to love it. You're going to enjoy it. You are going to share with your friends. Place your comment on the comment box and like. Have a nice day.